everyone. So let's start taking a look at worksheet 28. And this worksheet is all about volume of solids of rotation. And with each of these questions, we'll always have the choice whether to chop parallel to the axis of rotation or to chop perpendicular to this axis. And so depending on which one we choose, and we kind of have to play it by ear which one is going to work best for us, but depending on which one we use, the method ends up either being the shell method, and that's if we chop parallel, and if we chop perpendicular, it's the washer method. So let's try our hand at these. And the thing with these questions is that a lot of the thinking goes into just setting up the integral. And sometimes even after we've set up the integral, that integral is, substantial amount of work to compute. So that's what makes these problems tricky for students. But let's give question 1 a go. So we're looking at this curve and the region bounded by that curve, the x-axis, and we want to rotate that about the y-axis. That's what the question gives us. So now we're going to have to sort of review a skill that we've used several times, and that's to understand the shape of this curve. So the way I chose to do that was to understand the intercepts of that curve. I know it's a quadratic, and because of that negative sign, I know it. Because of this negative sign, I know it must face downwards. So it's a downward facing parabola, and all that's left for me to figure out is its intercepts, and then I know the approximate shape of it. So I factor it, and then I get the intercepts at, the x-intercepts are at 2 and at 4. And then if I set x equals 0, I get y is minus 8. So that's the y-intercept. So that helps me draw out this shape, and that helps me understand the region that we're working with. And since we have a very nice expression for y, so since we have a very nice expression for this length that's given to us, I want to chop this area vertically. So I want to chop it along the y direction. And that one would be parallel to the axis of rotation. So that's going to lead to the shell method. And in the shell method, we're integrating to, r times h between the respective bounds and multiplying that by 2 pi. So let's figure out what r and h are in our case. So the radius r is going to simply be this distance. Sorry, let me draw that out again. So the radius r is just this distance, right? It's at that point x, it's just the distance from my axis of rotation, so it's just x. I should label that point x. And the height, well, the height is just given by the y value, and because my y values are negative, I flip the sign, so that gives me a positive number, positive height value. And now it's just a question of multiplying out. Notice that because I know what my x-intercepts are, I know that my bounds are going from 0 to 2. And now it's just a question of, multiplying that out, applying a power rule, antiderivatives, plugging in the endpoints, and simplifying a bit.